Welcome, my name is Terry Soul, and this is a video on doing what's known as diffusion-limited aggregation in Scratch. So diffusion-limited aggregation is a process, which we see on the screen here, in which we have particles that are moving randomly, typically following some sort of Brownian motion. That's what's happening here, so just bouncing around randomly. And then when they touch a frozen particle, they become frozen as well. Basically, they're aggregating. So that's where the term diffusion-limited aggregation comes from. They're aggregating based on this diffusion, this random Brownian motion process. And it can be used to model physical processes like growing crystals. You end up with fractal patterns that can be used to model the growth of trees, for example, or coral or other structures. So quite often, if you want to do procedural generation of like an environment, you might use a system like this to get these nice organic shapes. So what I want to do is walk through the process of creating a diffusion-limited aggregation system in Scratch. And let me pause this. So the question is, sort of having watched it, how would you go about this in Scratch? So that's always the first part in a programming project, is to say, okay, I know what I want to do. How am I going to do it in code? What are the code structures that I need to use? So there are a couple that are going to come in handy here. It may be obvious, let me start this again, or maybe not so obvious, that when particles freeze, one approach to do that is the when touching a particular color. So in this case, when you're touching a particular color, that's when you know to freeze. So when you're touching orange in this case. Another thing that we're going to use in this project, you can maybe guess, is clones. So instead of trying to create hundreds and hundreds of sprites by hand, I'll use the clone function to automatically create clones of my sprites. Okay, so that's sort of two of the tools that we'll use in this project. And now pause the video for just a minute and take a stab at doing this yourself in Scratch. So take a look, or at least think about how you might structure the program. And then after you've thought about it a bit, hit resume, and I will show you how at least I chose to program it. Okay, so hopefully you've thought and maybe even started to code a little bit how to do a diffusion-limited aggregation program of your own. And now I'm going to walk through the process that at least I used. And of course, everybody can use a slightly different approach. First, we need a sprite, and I'm just using a circular sprite, so I'm going to paint my own. We could use a built-in one, but that actually gets tricky with the when touching a given color. So I just want to paint a sprite here. And really, all I need to do is make a round sprite. And I would like to make sure that it is centered sort of on the center point for the sprite. And the color doesn't matter all that much, but I would like to get rid of the outline. There we go. So I just have a sprite with no outline. And then because I want it to change color, there's two approaches. I could use the looks to change the color, but I would rather do it as a different costume, so that basically the idea is when a sprite freezes, it switches to its second costume. And so what I'm going to do for the second costume, I just duplicated my sprite, and then I'll pick a different color to fill it in. Color tends to be my weakness, but in terms of designing things, but I think purple and orange are supposed to be, as I understand it, complementary colors. So I'm going to use an orange to go with the purple. And there we go. So now I've got two costumes, a purple costume and an orange costume. And I will start with the purple costume, and here's my sprite. And so what I'm going to do is have this first sprite be what I think of as the parent or the master sprite, and I will immediately freeze it in the middle of the screen. That's what all of the other sprites, which are clones of this one, are going to aggregate to. So the first thing is when the green flag is clicked, I want this sprite to switch to its orange costume, because it's the orange costume that I'm going to be using for freezing. And I want it to move to the middle of the screen. So when the green flag is clicked, also we'll make it a little smaller. That's pretty big for my aggregation. So this, my master sprite, I want when the green flag is clicked to go to the middle of the screen, 0, 0, under looks, I want it to switch to the second costume. And to some extent, that is mostly what I need it to do. Other than that, it should then sit there and basically create clones of itself. So I'll go down to control, and I just want it to create clones forever. And maybe I'll have it wait a little bit between clones. Doesn't have to be very long, but just a little bit between creating clones, and then create a clone of myself. And then I'll need to put something in for when I start as a clone. And if we were to run this up, and I forgot the other thing I said I wanted was to make it a little smaller. So let's set the size. I'll start by, say, 20%. So there we go. Turns orange, moves to the middle of the screen, and starts creating a bunch of clones of itself, which presumably are just sitting in the same location. So not very interesting. So when a clone starts, it needs to do a couple of things. It should switch to its purple costume. It should go to a random position on the screen and then start moving around randomly. So I'm going to start with those pieces. So just because I have it here, I'm going to switch to costume 1. I'm going to go to a random position. And so again, nice to test things as you go along. There we have all of our random clones appearing. So that piece works. And then I want it to repeat until touching orange. I want it to move randomly. And as you build a program, typically you want to test it as you go. So I'll start with the random motion. So what I want it to do for this sort of Brownian motion is point in a random direction. So I don't actually want them to point 90 degrees. I want a random direction. And so for that, I need to go to my operators and say pick a random direction from 0 to 360. And I want, for Brownian motion, them to move a little bit. And you can play with the number of steps. I'll start with move 2 steps. And so there we go. Now they come in as clones, they switch to costume 1, which is purple, they go to a random location, and then they keep pointing in random directions and moving a little bit, and that gives us our sort of Brownian shaky motion. Of course, and if we watch this we might get to see it, they don't actually ever stop because my repeat until doesn't have a stopping condition. So that's the next piece that I need to add. I want to repeat until touching orange. So I'll go into my sensing. I'll put repeat until touching color. And if you click here, you can try and get the color right by filling in the numbers. That for me never works right. So instead I'm going to use the eyedropper and come over here and just grab the color orange. So now we can try this. Again, we start with our master clone, if you will, and then we have our purple clones, and you'll notice when they touch orange they immediately stop moving, right, because they're breaking out of this repeat loop. However, we're not getting the growth because they're not turning orange. They're just all piling up on that dot. So the next thing we need to do is have them turn orange. And there's a little bit of a trick here. So the simple thing to do is to go to looks and just switch to costume 2. That will turn them orange, and let me run this. So here we have our forever loop. Every 1/10 of a second another one appears and starts moving around randomly, and unfortunately we sometimes have to be a little bit patient to see if one touches, and sure enough they're touching and connecting. And this works okay. I mean, it is doing what it should do properly. There is a limitation, however. Scratch only ever allows you to have a maximum of 300 clones. And so even though I have this forever loop that keeps generating clones, it's actually going to stop after it's created 300. And so that puts some limits on our program that we may not want. So what we have here is doing diffusion limited aggregation. It looked kind of complicated when we started. Turns out the code is actually quite short and fairly simple, but it does have this limitation on the number of clones. So what we can do instead is when it touches orange, it puts a stamp down. And for that, we need another library. So I'll come down here and I will add the pen library. So this gives me a few new things that I can work with. And in particular, what I want is a stamp. So a stamp says, take your current sprite, stamp it on the screen. And in this case, once it's stamped on the screen, you can think of it as sort of on the backdrop, then we can delete it. So I will go back to my control and say delete this clone. So instead of the clones freezing and reaching the maximum of 300, they stamp themselves and then they delete themselves. And so we can keep adding more and more clones. You won't see much of a difference in terms of how the program runs unless you run it for a long time. That is long enough that you exceed 300 clones. Okay, so there, what initially maybe looked like a somewhat complicated and hopefully very interesting program, or at least somewhat interesting, turns out to be a relatively short program to do in Scratch, in part because we have these nice features, creating clones and when touching colors. So we have some built-in features that make this easy. Okay. So the next step, and this is something you should think about with almost every program that you write, is how can we extend this? So there's a whole bunch of different directions that we can take this program in now that we've created the basic version. So definitely a good place to start is to play around with different movement patterns. So I sort of arbitrarily set a step size of 2 in here. What if the step size was larger? What if it was smaller? What if instead of pointing in totally random directions, there was a little bit of a bias? Maybe they all tend to want to move towards the center, actually make the aggregation happen a lot faster. So there's a couple of simple things we could do. Other interesting things that give you very different patterns. What if the clones start fairly large and get smaller over time so that your center points are fairly big circles and later ones are smaller circles? What if instead of them all moving around randomly or even headed towards the center, what if all of my particles start at the top of the screen and work their way down, and then they aggregate from the bottom, and what you end up with is tree structures that grow up into the screen? So there's a whole bunch of suggestions for how to extend this project. And what I'm going to do now is recommend that you pause the program and try a few of those on your own, and then I'll come back and add some of those extensions myself so that you can see how they might be programmed. Okay, so pause and take a stab at making some of those changes yourself. Okay, so hopefully you've paused the video, done some extensions, or at least tried to do some extensions to our diffusion-limited aggregation, maybe successfully, maybe unsuccessfully. What I want to do now is do some extensions myself. I should mention one thing I added was an erase all at the beginning because we're using the stamp. Every time we run this, we need to erase all of that stamping so that we can start over. So as I said, there's a lot of different directions we can go in with this project. A nice place to start is just change how the movement works. So here we have them moving around with a fairly small step size. We could, for example, turn that into a variable, a slider. So let's do that. Always a good idea when you have what's sometimes called a magic number in your program, like moving 2 steps. Like, why should it be 2 steps? Let's instead make a variable. So I will call it step size. Doesn't really matter because we kind of only have one sprite, whether it's for all or just this one. And now that I have that variable step size, I'll put it in as how far they move, and I'll come over here and make it into a slider. And if I hit go, well, it starts at 0, so they're not moving at all, which I guess we could expect. And then I can vary it. And of course, for a small step size, we get this sort of very vibrational movement. And then as I increase the step size, they jump further and further. And the nice thing about this is it makes the aggregation happen faster. You also run into a little bit of a problem that they can jump too far and sort of stick right on top of one another rather than building out. So you can sort of see that if I go too far, you get a much denser structure because they're filling in the inside when they make large jumps. On the other hand, it's a lot faster, which is nice if you're impatient like me. So always a good starting point is to take some of the variables and say, well, or some of the values that you put in and say, let's turn them into variables that we can then experiment with. So there's one minor but useful extension we can do. Another one that is interesting that I mentioned is to have them more focused on the center. And so one way to do that is instead of pointing in a random direction, I'm going to actually have them point at the mouse pointer and then add some randomness to that. So let me get rid of the point in a random direction and instead say point towards the mouse pointer, but on top of that I would like a little bit of randomness at least, so I will put in a turn by a random amount, let's say minus 90 to 90. So they'll generally point towards the mouse pointer, but to some extent they'll also add some randomness to that. And then I can, for this one, I can use a very small step size, say 1, and I'll put the mouse pointer in the middle. So notice what they're doing. They're moving towards the mouse pointer, but they're also still turning a little bit randomly. So it's not an entirely, I'm just going straight towards the mouse pointer. And you get a much faster growth in this case because we don't have to wait for them to touch. And again, sort of a nice branching structure. Of course, because I chose to move towards the mouse pointer, if I pull it up here, that's going to bias their movement in a particular direction. Some of them now have totally missed the structure, and so I'd sort of have to come around to the other side to get those to come back down. You can get some interesting effects, and you can almost, in a sense, draw your structure by using the mouse pointer in this case. So there's an interesting change to make. Let's see. I'm going to take that out and go back to our old point in a random direction. But actually, instead of that, let's do one of the other extensions that I mentioned, which is instead to have them move down the screen. So in this case, I want them to start near the top of the screen and move down, and that will give me tree-like structures as they grow up. So a couple of things. First, instead of going to a random position, I want them to start at the top of the screen. So I'm going to say go to a particular X and Y, but the Y I want to be near the top of the screen. So that's about 175. And the X position I want to be random. So I'm going to grab this pick random because I happen to have it handy. And it should be, roughly speaking, the whole width of the screen. So I'm going to say, let's do for now minus 150. Did not mean to run that. To 150. So checking, and sure enough, they're starting near the top. Of course, what they're not doing is moving down the screen in the way that I would like. So to get them to move down, I'll adjust again the point in direction part. So I would like them to point down. So point in direction down. There we go. So now they're all going to start by moving straight down. And again, might be useful to test that. Sure enough, they're all moving straight down. But I do want some randomness, so I'll add in a turn. I'll grab my pick random. Let's do, say, minus 45 to 45. And there's a few different ways that we could do this. We could do point in a direction and have a random range there. I'll just do it as pointing down and then adding some randomness to it. And they're moving down, but again, there's sort of a little bit of randomness involved in the process. so they move back and forth a bit. If you want more randomness, we can just crank this up. And now more movement back and forth, which means they're a little slower to fall down the screen. Of course, I don't want them aggregating on this point anymore. I want them aggregating at the bottom of the screen. So how are we going to accomplish that? Again, the idea is I want them to fall, and when they reach the bottom, that's when they become frozen. And so a reasonable way to do that is simply to take the backdrop and paint in my orange sort of sticky color on the bottom. So I'm going to paint my backdrop. Here we go. I do not want an outline, but I do want a fill. And the fill color I want is, again, there we go. Switch back to my backdrop. Nope, not choose backdrop. Go. So I want to put in a rectangle. Here we go. But I need the color of the rectangle to be orange. So pick this other orange color that I want. Go back to my backdrop and fill it in. There we go. So now I have, for my backdrop, just a little bit of orange at the bottom. And go back to the code. Here we go. I'm going to have to do something about my master sprite because it's kind of in the way, but I'm not going to worry about that yet. First, I want to make sure that as they fall to the bottom, they pile up properly on the bottom. And I'm going to be a little lazy and increase the step size so that they get there faster. And sure enough, we can see them piling up. They're also, of course, piling up on my sort of master sprite. So the way to solve that, and there are a couple of different ways of doing it, but I'm just going to have it hide. And so it's still going to be in the middle, but it'll be hidden. And then when I start as a clone, I have to show myself. So here we go. They're falling pretty quickly because I was impatient and increased the step size, and you can see piling up. And this will start, as I said, to make these nice tree-like structures. What's interesting is how much they branch out to the sides and how many sub-branches they have is tied both to the step size and to the amount of randomness in the motion. By changing those, you can get structures that either branch more or branch less. So there's a couple of extensions that we can do to our diffusion-limited aggregation. And this is, if you're learning programming, something you should always be thinking about. Okay, I've written a program. Now how can I extend it? How can I make it do different things? How can I push my programming skills a little bit further? And as I said at the beginning, what you see here is this is sort of an almost choral-like structure. So if you wanted some sort of procedural generation for a game or a scene and you wanted choral, you're doing something underwater. Here's one way, for example, to generate it. Excellent. So keep taking these projects, keep extending them, and keep programming.